Welcome to the Journey Chez Chem. Well, today's warm-up is more the same, and you must be getting very good at it. So do the best you can, and I'll see you in a moment. Number 1 asks us to draw a line diagram for benzene. Well, we had that in yesterday's notes. Benzene is a ring structure, and therefore the 6 carbons, because it's C6H6, has an alternating double bond and a hydrogen coming off of each carbon as well. Now we know that when we have double bonds that we have parallel p orbitals. And these parallel p orbitals form what is called a pi bond. And therefore the benzene has delocalized pi electrons. Delocalized pi electrons because we form a donut above and below. And we did discuss this yesterday, and we're just making sure that it goes and sinks in so you'll know it when the assessment comes up. Number 2 are some dot diagrams, and I'll be back in a moment to do those for you. In number 2, we have a polyatomic ion, chlorate. And chlorine has 7 electrons, 7 valence electrons. And the -1 is telling me that I gained an additional electron. And I show that as a negative sign. Then oxygen has 6. And I have 3 oxygens. And that gives me an octet around each one. And here's my octet. And here, and here, and here. And when I draw the line structure, then I see easily that I have 1 lone pair of electrons and 3 bond pairs. And when I have a charged particle, I need to show that it's -1 so that I took care of that additional electron. This is a trigonal pyramidal. And the angle is 107 degrees. Trigonal pyramidal. And anything that is charged is always polar. Anything charged is always polar. And also it's polar because we have this lone pair, which is very negative on that side of the molecule. And this illustrates the point as to why polyatomic ions stay together. When we separate them, then they are going to stay together and have a covalent bond, and the particles, the atoms, stay together. In the case of chlorine, this one is greater than an octet. And the -1 does not mean each chlorine has 1 extra electron. We have chlorine with 7 electrons. And we gained 1, so I show that as a -1. Then this chlorine also has 7. And the additional one that I cannot put around this chlorine, I'm going to put up on the central atom. And then this chlorine also has 7. And the additional electron, again, I put on the central atom. And when I count this, I have 2, 4, 6 lone pairs of electrons. Not 6 pairs, but 3 pairs with a total of 6 electrons. And therefore, I'm going to have this shape. And remember, when we have the line diagram, we show the -1. And I need to circle my octets. So I'm going to circle this and circle this. And this shape of 3 lone pairs and 2 bond pairs is linear. And linear is 180 degrees. And it is charged, therefore it is polar. And that's how you do those too. Now, the 2C has a positive 1 charge, which means that we lost an electron. Therefore, nitrogen normally has 5 electrons, and now we've lost 1, so we only have 4. Nitrogen has 4 electrons, and hydrogen has 1. And that works out very nicely. And we get a tetrahedron. Circle my octets, and remember that hydrogen is happy with 2. It likes the duet. And when we draw the line structure, then we have to show that charge on the outside, that we took care of that. And therefore, it is a tetrahedron, tetrahedral, and 109.5 degrees. And it is polar because it is charged. And finally, D, we have SeF4. And you can kind of think about this, and we know that selenium has 6, of which 4 of those 6 are going to be used for the fluorines. Therefore, I'm going to have 1 lone pair and 4 bond pairs. I will draw it for you. Selenium, and I'm going to put each one on the side, and then I have my fluorines. Now the outer atoms are going to follow the octet, and only the central atom is going to be the one with an excess. And it has to be in the 3rd energy level, at least, in order to be able to expand into the d orbital, those extra electrons. And therefore, I get a total of 2, 4, 6, 8, 10 electrons around the selenium. However, my fluorines are going to have an octet. And the selenium actually gets 10. And when I draw the line structure, I see selenium and 4 fluorines. And this is a seesaw or sawhorse. And because of this lone pair, it will be polar. And on the assessment, you will be given a chart for the ones that do not follow the octet rule, that have an expanded octet. So it will say using the table above. And so you will know that those are the molecules that have an expanded octet. And the ones where it does not refer to that will be the ones that follow the octet. There are 6 shapes that follow the octet, and you will need to know them: the shape, the angle, the bond pairs, the lone pairs, and determine polarity. And that's number 2. There is just one thing that I want to mention, and that is that we've been talking about single bonds, double bonds, and triple bonds. And the relationship between the 3 is that the triple bond is the strongest bond. Strong bond, that triple bond. But the strange thing is that it is the easiest to break. Now that seems kind of counterintuitive. It's strongest, but easiest to break. Now I have an analogy to help you with this. When a hurricane comes through, or typhoon, or big windstorm, a blade of grass is like the single bond. And a palm tree, or any kind of tree, is like the triple bond. And therefore, when the wind comes through, the single bond is flexible, and that grass will just bend, and that will be fine. Whereas the tree is strong, but it's rigid, and therefore it will snap and break. It's brittle, and it is rigid. So that's why it can be both the strongest and yet the easiest to break. I hope that helped you understand how that works. Well, that's all I have for you today, and I'm sure you'll go over the homework assignments, and you've been looking at all of those. As we get closer and closer to the assessment, you should be getting much, much better at this. Well, that was some fun, and I thank you for being here, and I can't wait to see you tomorrow.